All right, welcome everyone. We are here to discuss how forthcoming efficiency standards may impact urban trees and parklands. My name is Chris Martinez. I'm an environmental scientist with the Water Boards in the Office of Research Planning and Performance, and I will be facilitating the meeting today. First, let's go over our agenda. As you can see, there is a lot to cover. We will begin by going over the logistics and go over some grounding with the introduction and background. We will then talk about trends in residential outdoor water use. We'll follow that with the methods and analysis and present the results. We will have a 10-minute stretch break planned around 2:30, followed by a panel discussions. At 3:50, we will wrap up and have time for additional comments and questions. Now onto logistics. Take a moment to look at the participant list and make sure your name there reflects your first and last name and the your affiliation if applicable. The chat box is disabled today. However, you may ask questions using the Q&A function and even ask questions anonymously. Questions may be answered live or in the Q&A box. If anybody wishes to speak and ask a question, please use the raise hand function. You will be invited to speak and asked to unmute. For those for those phone callers, you use *9 to raise your hand and *6 to speak. This meeting is being recorded and will be posted to the Water Efficiency Legislation Program page. A copy of the PowerPoint slide deck today will also be available there. For continuing, we are joined today by Vice Chair Diadamo. Vice Chair, would you like to say a few words?
I would. One moment here. I want to make sure that I'm on the screen. Well, I apologize for this. I can see my name, but it looks like you're not able to see me. Unless somebody has a suggestion here. Yeah, here we go. There we go. Well, thank you, Chris. Thank you all for taking the time to be here today at this workshop on upcoming water conservation regulation that our board will be considering, and how there may be impacts on natural and developed parklands and urban tree health. This is a subject that is very near and dear to my heart because in the last drought over at our home, we undertook some water conservation measures and saw that we did undertake some actions that had an impact on trees in our home, in and around our home. And this is something that I think that we need to be looking at closely, but better starting off with a better understanding of just what those impacts might be. So I've been really looking forward to today's discussion because I know our staff will be unveiling some information that they have regarding an analysis that they've undertaken along with several other partners, and they'll be walking you through that analysis. But I'd like to encourage an open and robust discussion here today so that we can better understand, first of all, what are those impacts? We do expect that there will be some impacts, but then also what can we do as a board as we move forward in developing the outdoor water use efficiency regulation? What can we do as a board to consider how to lessen those impacts, how to mitigate the impacts, and what can we do as all Californians to provide for better public information and outreach so that we can really be targeting the needs of the trees as we make adjustments in our outdoor landscape, whether that's removing turf or moving toward more native, drought-tolerant landscapes? How do we still figure out a way to maintain the health of existing trees and also provide for opportunities for additional plantings? I think we all, if you're showing up here at this workshop, I think you all already know and understand the value of trees and tree health to our society, both in terms of the shade cover, the quality of life that it provides, and also the ability to absorb greenhouse gas emissions. And so there's lots of benefits that we have for trees. And there is, despite the many, many conversations that I've had with our staff, I continue to be concerned about this topic, but I know that without a doubt, there is no intention to have impacts as a result. So I think that people are coming to this conversation with, really looking to how can we roll up our sleeves and better understand impacts to tree health and how we can mitigate and provide for useful information to the public so that tree health can be maintained. I just want to thank you all for your interest in being here today and also for your expertise. I know a lot of you that have signed up to talk have either particular information, useful on the ground information, or those of you who have a particular expertise in this area. We really look forward to listening and learning, continuing the conversation. And I'll just ask also that you all continue to be engaged in this important process as we go forward. So thank you, Chris, for the opportunity to kind of kick things off here today. And I look forward to taking some good notes.
Thank you, guys, Chair. And now we'll hand it over to my colleague, Karina Herrera.
Great. Yeah. Yes. Thank you. Hi, I'm Karina Herrera. I'm an environmental scientist with the Climate and Conservation team. The Climate and Conservation team is in the State Water Board's Office of Research, Planning, and Performance. We're a small team working on several different projects. We're the team managing the AB 1668 and SB 606 implementation at the State Water Board. We're also the group leading the water loss regulation, implementing the board's climate change resolution, and managing the monthly production and conservation data sets, among several other things. So this workshop is one of several we've had to solicit public input on how forthcoming proposed water use efficiency standards may affect wastewater, urban trees, and parklands. Today's workshop will focus on urban trees and parklands. However, if you're interested in the previous wastewater workshops, you can find the material, presentations, and recordings up on our program page. And next slide, please. So to give some background, for those of you who have not been following the AB 1668, SB 606 world as closely as others may have, as part of this 2018 water use efficiency legislation, the State Water Board was directed to adopt long-term standards for the efficient use of water in the urban sector. Urban retail water suppliers will use efficiency standards to calculate their water use objective. And here's an infographic showing generally how this objective would be calculated. The objective will comprise of standards for residential indoor water use, residential landscapes, commercial, industrial, and institutional landscapes with dedicated irrigation meters, and reasonable amounts of system water loss. Along with that, there are variances for unique local conditions and a bonus incentive for direct potable water, recycled water. The two standards that directly affect urban trees and parklands are the residential outdoor standard and the CI&I standard with dedicated irrigation meters. And those are the ones enclosed in the red boxes. Next slide. So intertwined with the regular rulemaking process is also an independent legislative requirement that the State Water Board consider how the proposed efficiency standards may affect local wastewater management, developed in natural parklands, and urban tree health. So as part of this, the researchers who have been working with us will present their findings today. Next. So first off, I would just wanted to give y'all a very brief overview of some of the trends in residential outdoor water use. Next slide. The general message we have around outdoor water use is that there are still significant water savings that can be achieved within the outdoor sector. Currently, about half of residential water use is used outdoors, and majority of this is lost because of overwatering, poorly designed irrigation systems, or evaporation. Earlier this year, the Pacific Institute came out with a report, The Untapped Potential of California's Urban Water Supply, where they note that the greatest potential for outdoor savings are in the outdoor sector, both residential outdoor and CI&I outdoor. They calculated that moderate landscape conversions could save 1 million acre-feet a year, and more extensive landscape conversions could save 1.5 million acre-feet a year. Next slide. So bringing it back to the objective and these efficiency standards. For the objective, outdoor efficiency will sort of be measured as an evapotranspiration factor. The outdoor standards are to incorporate the principles of the Model Water Efficient Landscape Ordinance, or MWELO. And so the outdoor water budget for both residential landscapes and CI&I landscapes with dedicated irrigation meters will be calculated using this equation. It'll be calculated as the difference between reference evapotranspiration and effective precipitation multiplied by a unit conversion factor of 0.62 multiplied by the standard, which will be expressed as a supplier-wide ET factor, and lastly multiplied by the landscape area for that specific water supplier. And so in general, the lower the ET factor, the less water is required for the landscape, and the higher the ET factor, the more water is required. Next slide. Based on data from the Department of Water Resources and using only irrigated area, we find that in California, the average ET factor for residential landscapes receiving irrigation is at 73%. To contextualize what an ETF of 0.73 is, we can think of a yard with warm season turf that's being moderately well irrigated. But we see in the histogram that there's a wide range in ET factors for suppliers across the state. And some suppliers even are at an ETF of over 100. Next slide. So if we include the addition of the 20% irrigable not irrigated buffer as proposed in the department's draft recommendations, State Water Board staff calculated that the average statewide ETF drops to about 65%. So our understanding of where California is in terms of outdoor water use depends on the data that we have and our understanding of irrigated landscape area. And so these two numbers give us a general sense of where our landscapes are at. So next slide. So next up, trees and parklands, why we are truly here. Next slide. So why are trees and parklands important, other than the fact that they're absolutely awesome? So trees shade homes and buildings. They reduce the urban heat island effect and in turn can save residents and businesses energy. They help create healthy soils, retain moisture, they reduce stormwater runoff. Trees and parklands improve water quality, improve air quality, and they also improve public health by improving water quality and air quality, but also by reducing stress levels, by creating recreational activities for us to do outdoors, and several other reasons. And they also provide wildlife and pollinator habitat. Next slide. And so many of the reasons why trees and parklands are important are also the benefits for efficient outdoor water use. Efficient outdoor water use protects water quality. It protects human health. It lowers household bills, not only by requiring less water, but also by reducing the labor and maintenance associated with maintaining some higher water using landscapes such as turf. Creates healthy soils. It reduces short-lived climate pollutants by encouraging the application of compost and mulch. It protects air quality and reduces noise pollution, and it protects biodiversity and supports ecosystems. So before handing it off to the researchers, we wanted to give y'all a sneak peek into some of their key findings, which might be helpful to consider and have as they walk you through their methodology and then more extensively go into the results. So next slide. So some of the key findings we found from their amazing work was that turf was the largest component of vegetation water demand for all months in all climate zones. Second is that many of the most common urban tree species in California are rated as medium water using. This suggests that trees may need additional irrigation during dry summer months, such as the ones we're in right now. And third, in all climate zones, the greatest percentage of low water use trees was in the largest or oldest class size. And this suggests that planting low water use trees may not have been as heavily prioritized in our urban areas recently. Next slide. And so same as the wastewater analysis, the team looked at 3 different scenarios for a different combination of indoor and outdoor standards to assess impacts. For scenario 1, it had an indoor standard of 50 gallons per capita per day and an outdoor standard of a 0.7 ET factor. And for this scenario, majority of the suppliers were in the no risk category. For scenario 2, they looked at an indoor standard of 42 GPCD, an outdoor standard of 0.62 ETF. Here, things shift, and majority of suppliers are about evenly split between the no risk and moderate risk category. And in the third scenario, we have an indoor standard of 35 GBCD and outdoor standard of 0.55. And here, majority of suppliers are in the moderate risk category. And you are probably wondering, how did suppliers get assigned no risk, low, medium, high risk? And so I will hand it off to Eric and team to go into the specifics of their methods and their results.
Thanks, Karina, and thanks everyone for the opportunity to present today. So I'll be joined by several of my colleagues from the project, including Dr. Jonah Sullins, who is with UC Davis and will soon be transitioning to a cooperative extension specialist in the Sacramento-Yolo region. Julia Scroven, who's an analyst at the California Center for Sustainable Communities, joined the project as a volunteer actually when we started in 2019, and now is a staff member and also a master's student as well. And Rob Cudd, longtime colleague at California Center for Sustainable Communities as well. And Rob is also a PhD student in the Institute of the Environment and Sustainability at UCLA. Next. As Karina alluded to, the full project scope included evaluating direct economic and environmental impacts to urban retail water suppliers, as well as the indirect other affected potential industries that were noted in the legislation. So the wastewater, community developed and natural parklands and urban trees that we're talking about today. The project was divided up into two essential bins of work. We had an environmental effects analysis, which was submitted, all the materials were submitted to the board in January, and then an economic impact analysis, which resulted in a statewide or a standardized regulatory impact assessment, or a SWRCB. And we submitted that in June 2022. Next. The full project team included a multi-university collaboration between Sacramento State, UCLA, University of California, Davis, and Cal Poly Humboldt. So at Sac State, myself and Jonathan Kaplan were the leads. At UCLA, Stephanie Cassell and Lauren Sack. At UC Davis, Mary Cadanasso. And at Cal Poly Humboldt, Eric Eschker. Can't say enough about the team. They worked all through COVID and under incredible deadlines, and pulled it all together. So what we'll be talking about today was especially led by the UCLA and UC Davis teams. Next. I'll just introduce for a moment here what the task was and some of the challenges associated with evaluating overall what the economic and environmental impacts will be from AB 1668. So within the framework of understanding impact assessments, we have to understand what's going to happen, and that's considered what's a baseline. So one of our first tasks was to essentially consider what current indoor and outdoor demand was across residential, commercial, and so forth, and other properties, but then also forecast what it would be by the full implementation of the regulations spanning through 2030. So in order to estimate this baseline, we implemented a multi-step modeling procedure with lots of data integration and science. So we brought all parcels within California within a hierarchical framework to label them within suppliers, as well as across the whole state for the 400 suppliers. We estimated indoor use now and in the future through a combination of methods with actual data, as well as a end-use modeling approach that could evaluate saturation effects. We looked at then using that indoor data to evaluate what outdoor water use was, which is sort of a basis of how we're able to evaluate effects on urban trees and landscapes that we'll talk about today. We looked at population changes and how that would affect either the increase or changes in per capita use versus total use. And then finally, we were able to compare the future total use, the projected use with the budget of the objectives to evaluate effects, which then led to us being able to analyze potential risk for, in this instance, urban trees and parklands. Next slide. And just to illustrate a little bit more clearly exactly how the impact assessment materializes, we're really evaluating what the mitigation and adaptation actions are. And specifically the take mitigation and adaptation actions, the impacts of the regulations themselves on top of what we already know will take place in California, thinking about climate change, thinking about water scarcity and so forth. So the baseline had to best capture as possible all of those kind of current conditions and how they'll change in the future, and then think about what the incremental or the marginal additional effect would be of the AB 1660 SB606 objectives. So you can see the baseline conditions and the estimates of future baselines in the blue, and then in the orange, the objective scenarios. By comparing those two, then you're able to identify how much a particular supplier would likely have to reduce or not reduce in the future. And that gets implemented through mitigation and adaptation actions, through which we consider a whole series of constraints and costs for that. So we spoke about this in significant depth in December webinars, as well as some in the May webinar. We talked about wastewater effects, so I'll refer folks back to that, or of course to the reports, or you can always get in touch with the team, and we're happy to describe the methods and results. Next. So at this point, I'll turn it over to Joanna, who will walk us through the evaluation procedure for evaluating effects on residential trees.
Thanks so much, Eric. So as Eric mentioned, this work was part of my postdoctoral research with Mary Cadanasso at UC Davis, and I'm going to be transitioning to an extension position in the fall. So I'm really excited to get to work with some of you in that capacity. In this portion of the presentation, I'm going to briefly describe the approach and methods we use to evaluate the effects of the new standards on urban trees in residential areas, and of course, share our findings. And as Eric and Karina both mentioned, we presented a much more detailed version of these methods in December, and that webinar is still available if you're interested. So to give you an overview of our approach, we started by characterizing California's existing urban forests to establish a baseline understanding of what trees are where. And then we also investigated how different irrigation practices can affect tree water stress, since we expect that irrigation practices will change due to the legislation. And the largest part of our work was to evaluate the level of risk urban trees might face for suppliers across the state. And we did this by estimating the water demand of urban residential vegetation and comparing it to both baseline outdoor water use and predicted changes under the new objectives. Next slide, please. So to characterize California's urban forests, we used tree inventories gathered from several sources, both private and public. So our colleagues at Cal Poly kindly shared a large collection of inventories conducted by private tree companies. And we also gathered public inventories from the Forest Service and from municipal websites. And together, these sources provided data on over 3.5 million trees in residential areas statewide. However, these trees were not evenly distributed across the state, as you can see in this map that shows tree counts by the 6 different climate zones in California as defined by the US Forest Service. So for the interior west and southwest desert regions, we included non-residential urban trees so that we'd have a large enough sample size. Next. These tree inventories suggest that California's urban forests are quite diverse. There were over 1,000 species in total, and more than 450 of those species had more than 100 individuals in the data set. Of course, a lot of this diversity is made possible by irrigation, and we found that most of the urban trees in California are considered medium water use species, as rated by expert opinion in the Select Tree database that's maintained by Cal Poly. So this held true in all climate zones except the Southwest desert, where low water use species were more common. And interestingly, the percentage of low water use trees was lower for small trees than for larger trees in all climate zones, suggesting that low water use species haven't been prioritized in recent planting efforts. And it follows that substantial water inputs would be required in most areas to maintain our future urban forests, and also that these trees with higher water needs are going to be at greater risk of negative impacts from reduced irrigation. Next. So in that vein, we know that addressing the new standards will likely require reductions in residential outdoor watering, which could come from replacing sprinkler irrigated lawns like the one on the left with lower water use drip irrigated landscaping like the yard shown in the middle photo, or possibly from residents simply stopping their yard irrigation altogether and letting their lawns go brown to save water. So we wanted to know how these different irrigation practices might affect the water stress and health of mature urban shade trees, to help understand how water-saving measures might affect our urban forests. Now, we know that some trees derive a lot of their water from lawn watering, but lawn watering is actually not ideal for trees since they're more deeply rooted than turf. So drip irrigation actually has the potential to be more favorable for trees if it's set up appropriately, but transitions in water regimes can also be very challenging for mature trees. Next. So we conducted a field study to see how these different types of irrigation might affect a very common street tree, the London plane tree. London plane tree is widespread across California, and it's rated as a medium water use species. So we studied large mature street trees that were growing in front of yards that had either lawns, drip irrigated landscaping, or were unirrigated. And we first used a pressure chamber to take water potential measurements, which essentially give us an instantaneous measure of tree water stress. We measured water potential at midday when the trees experienced the greatest water stress, and we conducted this study at the end of the summer when irrigation would be most important for trees. And I'll note that this study was completed during the first summer of the pandemic, so we kept it local in Davis. The next summer, we expanded on this work to do a visual assessment of tree canopy health on over 400 trees in both Davis and Sacramento to get a sense of whether longer-term health problems might be resulting from water stress related to irrigation. So for each tree, we scored several metrics, including dieback, leaf discoloration, and canopy density. Next. Promisingly, we found that both water stress and canopy health scores were similar for trees in front of drip irrigated yards and trees in front of lawns. So these box plots show the distribution of all the data by quartiles, and then the little asterisks or stars in them show the mean values. And the box plots on the left show the midday water potential on the y-axis. And the lower the water potential, the more stressed the tree is. So although drip irrigation scores did tend to be slightly lower than lawns, the difference wasn't very substantial. And similarly, for the canopy health scores shown on the right, there's only a very small difference in the mean scores for trees in front of lawns and drip irrigated yards. So this suggests that people can transition to drip irrigation as a water saving measure without substantially harming street trees. On the other hand, we found that trees in front of unirrigated yards were significantly more stressed and had lower canopy scores, suggesting that residential irrigation is important for these trees. And I do want to stress that there was a lot of variation in all cases, as you can see by how wide the distribution is on those box plots. And that's because there's a lot more than yard irrigation that can influence how stressed a tree is. And there's also some variation in irrigation practices within these categories. However, the overall trend does show that a lack of nearby irrigation could lead to health declines and eventual mortality potentially in these trees. Next. So finally, we evaluated risks to trees for suppliers statewide. And again, these methods are described much more fully in the presentation we gave in December, but I'll go through them again briefly here. So as an overview, we calculated the residential vegetation water demand for each supplier using a bottom-up method based on transpiration rates. So this method performed robustly in pilot tests, and although it does have considerable data requirements, there was an acceptable amount of data available to make us feel comfortable using it. So once we calculated the vegetation water demand, we could compare it to both baseline outdoor water use, that projected baseline outdoor water use that Eric was talking about, and then also to the reduced outdoor water use that was predicted as a result of the legislation, to see whether reductions would be likely to put trees at risk of having insufficient water. Next. For this bottom-up method, we used the work of researchers in Los Angeles who developed equations for tree and turf water demand based on field studies that related plant transpiration rates to environmental variables and characteristics of the plants. So water demand is simply the transpiration rate under fully irrigated conditions. So it reflects how much water the plants use when water is not limited. And since trees and turf are the dominant components of residential vegetation, this method can give us a good overall sense of urban vegetation water demand, even though, of course, we acknowledge that not all non-canopy vegetation is turf. Next. So the first step in calculating residential vegetation water demand is to determine how much residential area is covered by vegetation, and then what proportion of that vegetated area is tree canopy. So we first defined residential areas by aggregating residential parcels within each supplier's boundary, and then we included a buffer to capture the full canopy area of trees that extend over the street. We then calculated the total vegetated area within the residential areas using the Normalized Difference Vegetation Index, or NDVI, which quantifies the amount of living vegetation using remotely sensed imagery. So this example on the right shows the same area of Sunnyvale with just imagery on top, and then with NDVI values overlaid below. So the green NDVI values represent vegetation. Now, NDVI can't distinguish tree canopy from other vegetation, so we calculated the total residential tree canopy area using an existing urban tree canopy data set, and then point count estimates for areas that weren't included in that data set. Next. So once we have the total vegetated area and canopy area, we can calculate the water demand of turf. So research from Los Angeles showed that the water demand of turf when it's fully irrigated depended on whether or not it was shaded, which was used to calculate this microclimate coefficient, the KMC in this equation. And then also the reference of evapotranspiration, or ETO, which is available statewide from Spatial CIMMYS. So to calculate KMC, we estimated the unshaded turf area as the total vegetated area minus the tree canopy area, and then assumed that 50% of the area under the tree canopy was also turf, or shaded turf, since we can't know for sure what's under the canopy. Now, shaded turf doesn't use as much water as unshaded turf, so this uncertainty doesn't have a huge effect on the total turf water demand estimates. Next, please. The next step was to calculate the water demand of trees, which is a bit more complicated. So this method groups trees into 3 different types that have different water use patterns. We have broadleaf trees, conifers, and palms. Water demand is the sum of transpiration, or E, for these 3 components, each of which has its own equation. So overall, for each supplier, we needed to know the total number of residential trees, the relative abundance of each species, as well as its size distribution, which is based on diameter at breast height, or DBH, which is a standard measure of how large a tree's trunk is. We also needed to know which of the 3 types each species is and whether it's deciduous or evergreen. And then for broadleaf trees and conifers, we also needed to know the mean sapwood area, which is the area of the trunk that transports water. And finally, we needed to know the monthly average vapor pressure deficit and solar radiation values. So that's a lot of information, and I'll quickly show you how it all fits together. Next, please. So this diagram shows the tree water demand modeling process that we used, with the green bubbles showing data inputs, the gray showing intermediate steps, and the blue showing information that feeds directly into the transpiration equations. Starting on the left, we relied on the tree inventories that I discussed earlier to evaluate the relative abundance of different urban tree species and their size distributions. Using this information, we were able to calculate the average tree crown area for each supplier based on models that we developed. Now, this tree crown area is the average amount of canopy occupied by one tree. So if we divide the total tree canopy area by the average crown area, we get an estimate of the total number of trees. Then using the relative abundance data from the inventories, we can then get an estimate of the density of each species, which feeds into the equations. We also developed models to relate DBH to sapwood area for different species, and we classified species into types and determined whether they were deciduous or evergreen using the select tree database. And finally, we calculated vapor pressure deficit and solar radiation for each supplier based on spatial CIMMYS data. Next. So as I mentioned earlier, the tree inventories were unevenly distributed, and some suppliers didn't have adequate inventory data to characterize their urban forests. So for these suppliers without tree inventory data, we needed predictions of their urban forest composition. So we first looked at whether tree inventories within climate zones were similar to one another, focusing on the 4 climate zones that had a lot of tree data. So this plot shows the results of a non-metric multidimensional scaling ordination, which evaluates how similar the species compositions of different areas are. So each dot on this plot represents one supplier with inventory data, and the closer together the dots are, the more similar their inventories are. The colors match the climate zones on the map, and so we can see that suppliers within the same climate zone tend to have relatively similar urban forest composition. This is an interesting result in and of itself because it suggests that climate has played a substantial role in urban tree selection. It also means that we were able to model unknown urban forests by climate zone using a joint species distribution modeling technique, which allowed us to get better predictions of tree water demand. Next. So once we calculated water demand estimates for each supplier, they were converted to gallons per capita per day using population values from 2020. And this figure shows the distribution of annual vegetation water demand values in gallons per capita per day for different suppliers in each climate zone. And these varied widely, so note that the y-axis is on a log scale. So this variation was largely due to differences in vegetated area per capita, but also due to differences in climate and tree to turf ratios. Next. This figure shows median monthly water demand estimates in gallons per capita per day for turf, broadleaf trees, and conifers for suppliers in each climate zone. And palms didn't use enough water to be visible in these graphs, so they're not included. Now, the y-axis in these graphs shows the daily per capita water demand. The x-axis shows the months of the year from January to December, and then each bar shows the water demand values by vegetation type, with turf on the bottom in medium green and then trees above. And as you can see, turf was on average the largest component of vegetation water demand for all months in all climate zones, while conifers in dark green on the top were on average the least. Conifers were overall less common than broadleaf trees, and they were also found to have slightly lower transpiration rates than broadleaf trees given the same conditions. So we can really see the effect of climate in the steepness of these curves, with the high summer water demand values for the inland valleys, interior west and southwest desert climate zones reflecting the hot, dry summer conditions, and then this shallow curve of the Southern California coast region reflecting more consistent year-round conditions. And then in addition, the interior west in the upper right has high overall per capita water demand values, largely due to the relatively low population densities of suppliers in that area. So there's a lot of vegetation per capita. And then conversely, the Southern California coast in the lower middle has a low per capita vegetation water demand, in part due to high population densities. Next. So our risk assessment compares our estimates of vegetation water demand to baseline outdoor water use and predicted outdoor water use under the new objectives to assign different levels of risks to trees for each supplier. So I wanted to give you a visual for how we made the risk level assignments. And this graph shows fictional water use data for a supplier. So the y-axis here is water use in gallons per capita per day. The dark blue bar is that projected baseline outdoor water use. The light blue bar is the projected outdoor water use with the new standards. And the green bar is our vegetation water demand with trees in dark green and turf in light green. So in this example, the baseline outdoor water use is close to vegetation water demand, but the predicted outdoor water use under the new standards is less than the demand, which could put trees at risk if residents stop irrigating them. However, a lot of the vegetation water demand is from turf. So if turf were replaced with low water use vegetation or other ground covers or watered at a deficit level, there could still be plenty of water available for trees. So we would put this example in the moderate risk category, which I'll explain on the next slide. Next, please. This is the flow chart that we use to assign risk categories. The first step was to ask whether a reduction in water use will be needed at all to meet the new objective. If not, there's no additional risk to trees from the legislation. Once there's any necessary reduction, there is some risk to trees because any resident might respond to these new levels by decreasing or stopping their irrigation. So to determine the level of risk, we asked first whether the projected outdoor water use is still greater than the vegetation water demand. If so, the risk is low because it would be possible to meet the standards through improvements in irrigation efficiency. We also considered the risk to be low if the total reduction was less than 5% and if the current baseline outdoor water use was less than 10% of vegetation water demand, which we saw in some of the naturally forested areas of the state where many residential trees are not irrigated. So if the answer to all of those questions was no, we then asked whether the projected outdoor water use is above our estimate of tree water demand alone. If so, the supplier is at moderate risk, like the example on the last slide. If not, the supplier is at high risk because there wouldn't even be enough water to satisfy the tree water demand if all other vegetation were removed or unirrigated. And finally, trees in some areas are clearly getting water inputs from non-irrigation sources, which would help to buffer their irrigation reductions. So if the baseline outdoor water use was well below vegetation water demand, we move the supplier back to the moderate risk category. Next. So as Karina showed earlier, we considered 3 scenarios with different indoor and outdoor standards, moving from the relatively modest values in scenario 1 to relatively stringent values in scenario 3. And accordingly, there's this shift from the majority of suppliers being at no risk in scenario 1 to most being in the moderate risk category in scenario 3. And just a note that there are relatively few suppliers in the high risk category, even in scenario 3. Next. So if we plot these results geographically, we see that a lot of the suppliers at greater risk are in the southern part of the state. Although I should note that there have been a few adjustments since the time of our report that have shifted supplier risk levels a little bit. I want to stress that the point of our analysis was not to create a hard and fast prediction for each supplier, because there's clearly a lot of assumptions in our modeling that could make individual predictions less accurate. But overall trends across the state should be more robust. Next. So to summarize our findings, the tree inventories showed that low water use tree species have not been prioritized in California's urban forests. And we suggest that planting more climate appropriate trees now would be a good strategy to reduce the water needs of our future urban forests. We also found that mature shade trees can be negatively affected by a lack of irrigation. However, the good news is that efficient drip irrigation could likely save water without harming existing trees if care is taken with the irrigation design. And finally, most areas will have enough water for existing trees under the new standards, but not necessarily for turf, especially in the more stringent objective scenarios. So this means that in order to protect urban forests, transitions will need to be made to non-turf landscaping choices or deficit irrigated turf. And these transitions should consider trees' water needs. For instance, even if a yard is generally unirrigated, trees can be watered deeply with a soaker hose once a month to maintain their health. And we also note that shading turf reduces its water use substantially. So increasing canopy cover can actually decrease the overall water use without removing turf. There are also some varieties of turf that can maintain their appearance better with lower water inputs. And finally, this study is only evaluating the changes from the baseline expected from the regulations and not how urban trees may fare overall. And there's a lot of uncertainty in both future climate conditions and how people will react to them. So that's it for my portion. I will hand it over to Julia.
Thank you, Joanna. So I'm Julia Scrovian. I worked at the California Center for Sustainable Communities at UCLA and worked with Rob, who will be speaking next, on evaluating the effects on urban parklands. At the time of our assessment, the parkland areas were included as a key group of stakeholders that may be affected by revised water objectives. So dependent on dedicated irrigation meters, parklands would be included in the commercial, institutional, and industrial outdoor water use portions of the CI&I. As of now, parkland areas will be deemed special landscape areas per MWELO and are unlikely to be significantly affected by the standards for CI&I, but they likely will be subject to some performance measures, including best management practices. So as a first step in our work, we evaluated parklands that were situated within the urban retailer water supplier boundaries. We then identified park management agencies across the state to serve as case studies. We conducted outreach and semi-structured interviews with park managers from those case studies. And finally, we analyzed interview findings to create a baseline understanding of how water use in parks from different parts of the state and what resources they may or may not have to adapt, whether that be, for example, to the objective or to performance measures or to climate change. So next slide, please. So we were able to use the California Protected Areas database, which is produced and managed by Green Info Network. So this parklands database includes large and small urban parks, as well as state and federal parks, reserves, conservation areas. It's a large variety. On the left here is that entire CPAD database as of the 2020 release. That represents about 50 million acres of land. So the first thing we wanted to do was evaluate how much of that land sits within the supplier boundaries. So in the map on the center, you can see an intersection of the park boundaries with the suppliers. There we get about 1.4 million acres of parkland. Now this still includes agencies, federal, state to local, both developed and undeveloped parklands. But you can see an example of the detail of this database on the right of a small park in Los Angeles that includes information about the management agency, the type of the park, in some cases even detail about the age of the park, which might tell us information about the age of infrastructure in the park. So this was incredibly useful, understanding not only the distribution of parks within the supplier boundaries, but also the distribution of the type and the management of those parks. So next slide, please. So we use that Parklands database to identify case studies for research, for outreach, in order to get some variety in terms of potential irrigation regimes and vegetation. We use the same climate boundaries as the trees analysis, shown again here, to make sure we included park management agencies from each of the climate zones. Of course, terrain and local conditions across the state are incredibly diverse. These climate zones still help situate some comparative conditions. So the next thing we did was narrow in on local parks and local recreation areas managed at the city and county level to target areas that were more certain to have some irrigated, developed parklands. And here you can see an example list of potential case study management areas. So we looked at the number of park units, percent of park units that accounted for all parks within a particular climate zone, as well as population. Because we suspected that park resources and characteristics like age, climate, expected traffic may affect irrigation systems, plant palettes, and capacity for adaptation, we're interested in case studies that represented some of the older and larger park systems in California, serving large populations, as well as some of the smaller, newer park systems that serve smaller communities across the climate zone. So with a qualitative study like this, the goal was not generalizability, but instead to provide an exploration of the on-the-ground status of a varied collection of parklands. Next slide, please. I'm going to hand it over to Rob, who will discuss the results of the semi-structured interviews.
Thanks, Julia. So we asked each of the park departments that we identified for outreach to make someone available to us for like an hour-long semi-structured interview where we asked a number of questions about like the structure of the how the parks are irrigated, what kind of technology they use to do that, what their concerns are vis-a-vis water scarcity, drought mitigation, and climate change, among some other questions. So like I said, it was we used the same panel of questions each time, but the conversation kind of went in various directions depending on what the concerns and the concerns and the sort of like topics that the interviewees wanted to bring up. And the the responses kind of fell. I mean, this represents the major topics that we were discussing, and if we go to the next slide, we can see some of the findings that we observed across the various climate zones and parks departments, regardless of what kind of like vegetation or size or like land use purposes, like the whether or not they had a number of parks dedicated to like urban kind of recreation, or whether they had a number of a greater proportion of parks that were only partially irrigated and contained a great deal of unirrigated space. So one of the things we found is that most parks departments are taking their climate change is on their minds, but it's not quite a budgetary priority for most. Although they're kind of trending in that direction, especially among some of the larger ones. almost all of them have experimented with one kind of drought tolerant landscaping or another. So transitioning from thirstier plant palettes to more drought tolerant plant species in various areas, and installing drip or bubbler irrigation, and in some cases switching to recycled water. And we also found that the concerns of the Parks Department administration and also the people who make use of those parks, there were a number of commonalities among all the interviewees, that the public was kind of two minds about the adaptation to drought conditions and potentially climate change. There were some people who were very concerned with what they saw as wasteful use, and other groups of people who were upset with the condition of vegetation in parks because of restricted watering. But one of the most important things that we found was that that water is most often measured in dollars, as it's thought of as a budgetary line item first and foremost, and is something that is not necessarily measured all that closely. Parks departments install dedicated meters for outdoor watering, where there's kind of like a compelling fiscal need, or where they're splitting their resources with other public agencies, and that and also very importantly that there's no like one technological solution to all of this. One of the things that people emphasized is that well organized and trained parks staff are a complement to automatic and weather controlled irrigation equipment. They're not a substitute. So if you go to the next slide. So yeah, so kind of thoughts, key takeaways is that, as Joanna said earlier, like the transitioning from one watering regime to another is an expensive and complicated task, and the Parks Department certainly know that and are keenly aware of that fact, and are trying to in many cases find a way to either cut down on their water expenditures or to adapt to climate change, however they characterize it, and that none of them are reliant on a purely technological approach. None of them have they all recognize that it's going to take doing things differently and approaching the tasks they have differently, not just installing better and newer irrigation equipment, and that in some cases, well, in a few cases, downscaled climate projections were something that Parks Department staff were interested in, but in other ones that wasn't quite part of the conversation yet. But in either case, those downscaled or local climate impact or change predictions are going to be important for coming up with an integrated landscape management plan. And that about has it for parks. I think the next slide is Eric's, I believe. I'll hand it back over to him.
Thanks, Rob. As I alluded to it earlier in the presentation, the environmental impact assessment and the manifested through the trees and parklands and wastewater analysis, as well as an analysis of suppliers, was linked to an economic impact assessment in order to satisfy requirements of rulemaking. We drafted a statewide regulatory impact assessment, or SWRCB, and the SWRCB is currently submitted with the State Water Board. So here I'll just briefly talk about a few highlights of that SWRCB. In general, a SWRCB will evaluate impacts in a few different types. They'll have direct impacts on the directly affected community, which would be in this case the water supply management community, the urban retail water suppliers, and you also have potential indirect and induced impacts. And so within the directly affected community suppliers, that would consider, say, actions for properties that are directly supplied by those municipal suppliers or regional suppliers, and that would consider, say, for instance, residential, commercial, industrial, institutional landscapes. But there are trees that are irrigated within the municipal sphere. which largely informed a lot of the tree inventories we used for the modeling extrapolation procedure. And so within that, within those potentially affected communities, that sector, those are listed as local fiscal government impacts, which is where these results are reported within the SWRCB. So for the, if you remember back to the scenarios, the tables of potential risk for different suppliers, the moderate and high risk categories were approximately 140, 139 total for what is called in the SWRCB the scenario 2 or preferred option based on the Department of Finance's language. So for that scenario 2, for the 139 moderate or high risk category suppliers, we assumed that the actions that these suppliers would have to take in tandem with municipalities for specific purposes of mitigating or adapting to risk to the municipal urban trees would entail actions such as education and outreach focused on urban tree irrigation and planting, potentially updating urban tree inventories and updating urban forestry management plans. So in general, we derived all of the potential items that we might evaluate for fiscal impacts from urban forestry management plans. And we surveyed, we identified about 15 urban forestry management plans dating from the past decade. And from those, we extracted any quantitative data for costs and particular types of activities and actions. So in addition to the risk mitigation procedures that Joanna had discussed as part of the irrigation regime changes, we also saw that communities would take these other types of actions for education and outreach, tree inventory, and planning activities. And we could identify unit costs for each of those, apply those unit costs to each of the suppliers in the high-risk categories, and then project potential fiscal impact for those communities in the likely actions that they might take. And you can see in the column on the right-hand side, the total costs of those are approximately $3 million per year for education and outreach focused on urban tree irrigation and planting to adapt to lower water use landscapes for municipally managed trees. About $83 million, assuming $600,000 for an urban tree inventory, and $7 million for updating forestry management plans in these communities. And within the context of the SWRCB, we were evaluating potential effects through 2030. So that's not to say that in 2030 these potential needs end, but that's the rubric from the Department of Finance's SWRCB reporting characterization. So a few notes on this. Throughout our project, there was limited information on how these sorts of regulations would promulgate for these additional sectors. So these are assumptions and extrapolations based on the best available information we had as we were finalizing numbers in early 2022. We did not adjust these costs for inflation. So these are simply nominal costs. And we also did not get to extensively benchmark these findings with the municipal urban forestry community, similar to how we were able to do with other parts of components of the project. So in thinking about these costs, we do have to recognize that there is still uncertainty in what exactly the AB 1668, SB 606 regulations, how they will specifically apply, including, as Julia alluded to, the emergence of a special landscape area designation for urban parklands. Next slide. I should also note too that this does not include residential trees, which were captured under the direct supplier community as costs for turf and landscape conversion, and those costs were significant, which will be detailed in the SWRCB as well. Last, I want to just highlight a few considerations around fiscal matters related to urban trees, because in this instance, this particular community of potentially affected, as a potentially affected sector, it may overlap or it may differ from the directly affected communities of suppliers, right? So in some instances, if a supplier and a municipality overlap, then essentially all of the trees, landscapes, properties within that supplier territory would also coordinate with that city's municipal urban forestry department or utility. But in many instances, those boundaries do not fully overlap. So a supplier may not have direct jurisdiction, a water supplier may not have direct jurisdiction over the management of the urban forest in parts of its service territory, but more importantly, it may not even have a synonymous boundary with that other entity, and there may be multiple municipalities managing urban forests in that territory. So in order to think about this kind of integration and coordination aspect, the idea of fiscal and accounting and municipal accounting is important. So within many of the, for instance, urban forestry management plans, we would see some common models such as the U4 model from the U.S. Forest Service, which is a tool to be able to allow communities to quantify potential benefits and costs. But you could also see other sources of literature, of statewide literature. So we surveyed all of these, and I provide here some of the highlights of unit costs from those plans. And this is important because we have to think and consider in fiscal impacts who will be incurring costs and who will be incurring benefits as part of this. And so as we consider potential changes in the urban tree canopy, we must consider about the long-term maintenance of that tree canopy and the parties who are responsible, in this case, the inter coordination between suppliers and municipalities for municipal forests, as well as the coordination with residences and property owners for residential or commercial owned trees on those sorts of properties. Next slide. To wrap up and highlight a few takeaways. So the team evaluated effects of urban water use objectives on urban landscapes and trees, which incorporated a baseline of forecasted changes. Mature shade trees may be affected by water use reductions, but risk to existing tree canopies in many of California's urban areas is low to moderate. This can often be mitigated through efficient irrigation practices, but that does require education and outreach in many instances. Climate appropriate landscapes and low water use tree species have not generally been prioritized historically in California's urban areas. And finally, effects of urban parklands, effects of the regulations on urban parklands depend on their designation under the AB 1668 SB 606 framework. But even still, even with a special landscape area designation, urban parkland managers noted that they face multiple challenges related to water and landscape management. And these include fiscal constraints, public perceptions, and drought. And there's also a need for better integrated landscape planning with climate change. Next slide. Last, I just want to provide special thanks to a whole body of people who assisted and organizations that assisted with this work, including the California Water Efficiency Partnership, the Alliance for Water Efficiency, the retail water supplier community, as well as the wastewater management community, the urban parkland management community, our colleagues at UCLA and Cal Poly SLO. At Cal Poly, Matt Ritter and Andrew Ficker were incredible colleagues alongside this, as well as Diane Pataki and Lisa Litvak with University of Utah and Diane with Arizona State. That concludes our portion of the presentation, and thanks very much. And I'll turn it back over to Chris.
Thank you, Eric. We've now reached the portion of our first Q&A. So if you would like to ask a question, there are two ways. I'd like to remind everybody, you can raise your hand. We will take questions in order. You will be asked to unmute, and then you can ask your question. There's also the Q&A box. So if we run out of time, you can continue posting your questions there, and we will get to them as we have time. Okay, our first question is from Fiona. Fiona, go ahead and unmute.
Hi, thank you. This is Fiona Sanchez with Irvine Ranch Water District, and very much appreciate this research. I think it's really interesting. I was just curious. I don't know whether your study at all, or if you're still looking at what may be the cost impact or even the ability for people to update and modify the existing irrigation systems to allow for drip. I mean, I know if we put drought tolerant plants in, that's something we could do. I'm just wondering about both technical and economic capacity to do that for these sites so that we can maintain tree health.
Thanks, Vienna. I could speak to that, and then any others can join in, add thoughts. Regarding fiscal capacity, it wasn't directly presented here, but it's a good question because within our evaluation of direct effects to suppliers in the context of the SWRCB, we totaled up the we used the industry-based standards of costs and water savings related to typical landscape conversion programs. So removal of turf, replacement with low water use vegetation, which we assumed in this case would also incorporate irrigation system upgrades as part of those. So in that case, that's the fiscal capacity. And we heard a lot of stories, although it varies significantly across the state, but we heard a lot of stories and surveyed programs where there is sort of strong kind of advising by the suppliers, or you're able to connect with a local kind of industry provider to help with doing landscape designs and irrigation system designs and so forth. So for residential properties, which is kind of the largest potentially affected kind of landscape area of all of the affected areas, those costs are captured under suppliers, and I can say that is a significant portion of those evaluated costs that are reported in the SWRCB. For the technical capacity to do that for those landscapes, that the current model, which I'm sure you're very familiar with, is to be able to either provide direct technical capacity to landowners for education, or to be able to connect them with local landscaping firms that would be assisting with implementing these conversions as part of a rebate program. How that works out with municipalities then, considering what we were speaking about with the fiscal impacts here, the fiscal impacts for changing over irrigation systems within existing municipal programs, we did not directly assess that cost just because we did not have enough data or certainty on how those would promulgate. So within the context of the urban forestry management plans that we surveyed, we saw many more references to the planning needed to implement that. And then we were not able to evaluate whether that required additional technical or fiscal capacity to change over irrigation systems.
Thank you, Eric. Fiona, you still have your hand up. Did you have an additional follow-up question?
Yeah, I was just going to say, I want to just thank Eric. And I guess, what prompted my question is I think we all know where we want to get to, but it's the transition of existing landscapes. That was why I had asked that. So I appreciate his response.
Thank you. And so I also wanted to remind everybody that all this information will be made available on the conservation portal on the legislation site. You should be viewing it now, along with the recordings, the PowerPoints, the results, the agenda, and there's also a button there so you can provide comments when you have time to go over and read the materials on your own. It looks like we have an additional question from Nicole. Nicole, go ahead and unmute yourself.
Hi, thank you. This is Nicole Cavender with the Huntington. I'm the director of the Botanical Gardens. Thank you so much for having this information session. The data looks really good. It's really nice to hear. There's a lot of important information being considered. Now, understanding that maybe people are not selecting the best trees for water efficiency, and that seems to be part of the solution moving forward. How are we thinking, do we have enough information to really understand what those trees are and where, and how are we thinking this is going to make its way into the residential group? So I wondered if there could be some discussion around tree selection and how we're going to help people make those selections.
Thanks so much for that question, Nicole. I can start out and anyone else can jump in if they want. It's a fabulous question. There is a lot of research being done currently on that. UCANR has research about looking at some really promising sort of newer species that haven't been, maybe not newer, but they haven't been planted as much in California yet, and looking at how they'll fare. But I think a lot of what we have relied on in the past and probably will need to rely on now as well is sort of expert opinion. You know, people who have been in the business for a long time and know how different species respond to different conditions. And I think, you know, the WCLS database has a lot of trees, although certainly not all, are in there with expert opinions about their water needs in different climate zones across the state. And yeah, I think transmitting that information to the public will need to be somewhat of a multi-pronged effort. I think, you know, making sure that landscapers, people who are designing landscapes, are well informed, making sure that nurseries are providing suitable climate appropriate trees, and then providing easy resources for residents who are interested in trees to select them by various characteristics. And there's a number of databases that already do that, including the Select Tree database. You know, you can search by different attributes, like I want a flowering plant, a tree, or, you know, one that's low water use and provides shade, or whatever you happen to want. So I don't know if that helps.
Nicole, I can add an item too, but I see your hand up, so why don't you go ahead?
Yeah, I guess I can still, okay, thank you. I'm still unmuted. I just had a follow-up question, because even if we're successful at helping people understand more water-wise selections and conversions, I also wonder, is there been modeling done on that cost of water? Because we know even if you're selecting the most drought resistant type of plants, we know that you need that water early on, especially probably 2 to 3 years. And so you might not see a lot of water savings in the first couple of years of conversion. So have you considered that in these modelings?
That's absolutely correct. I'll make a point or two related to your last point, and then to that as well, to this current one as well. So on the last point too, I do think another important aspect of this is the industry pipeline of where consumers end up, you know, identifying their plant and sort of choices. And there is sort of a customer class that, you know, it's Saturday afternoon, hey, let's go to the nursery and you know, do some planting. They may not necessarily do all of the upfront research. And our colleague Stephanie Pincel is not able to be on the line today, but they did some really interesting work about a decade ago looking at nursery offerings in and around the Los Angeles municipal area. And that's an important part of this whole endeavor. And so the extent to which suppliers are working with organizations such as yours and Thomas Paine Foundation and, you know, many of these kind of organizations throughout the state that have been helping to identify, you know, what sort of plant palettes are likely in the future, linking that up with research. To the extent that I hear conversations, I think on a lot of the organizations are connected with that research, and then it's really connecting with the supplier community as well. So on your second question then, did we explicitly include additional water within the modeling for, say, plant establishment? We did not. One aspect we really didn't cover today is that there's a phase-in of the regulations over time. So we had to, we essentially extrapolated this from 2025 through 2030. And we had to assume that any of those kinds of transitional aspects of moving towards lower water use by 2030 had to be captured within this phase-in. So it depended upon what the mitigation action was as to whether the savings would be immediate or over time.
Thank you.
Hi, Nicole. My name is Charlotte Ely. I supervise the conservation program here at the State Water Board. I wanted to just build on the very good point that Eric just made, which is that when looking at the potential impacts associated with this regulation, we did consider these changes from I guess where we were through 2030. And so we were looking at a gradual change over time. And so when looking at these potential costs associated with meeting the standards, we really did focus on those 2030 standards. And then we looked at the different scenarios. We looked at a scenario which sort of represented more or less baseline conditions. You know, what would happen if all suppliers were sort of what is average today, to the sort of middle scenario 2, which is sort of more or less based on the existing recommendations from the Department of Water Resources to the State Water Board and the legislature. And then a third scenario, which is a more ambitious scenario for indoor and outdoor residential water use. So those costs are both captured in that long range sort of analysis looking through 2030, and then also through the different scenarios that were evaluated.
Thank you, Charlotte. Thank you, Eric. Next question comes from Elizabeth. Go ahead and unmute yourself, Elizabeth.
Hello, my name is Elizabeth Skarzat. I am the general manager of the Chino Basin Water Conservation District in Montclair. And prior to that, I was the executive director of City Plants, LA's tree planting program. I had a question about also about the trees most recently being planted being moderate water use trees. Were you looking just at street trees, which is what's normally on inventories, or were you also looking at the trees on private property, which comprises about 90% of the average urban forest? And the reason that I ask that is, in working with constituents over the years, they tend to be very opinionated about what they want on their land because it is their land. And they tend to want about medium-sized flowering trees. That is the most popular category of tree that you might find a request for. So yeah, that's my general question.
Yeah, that's a great question. And yeah, these inventories were primarily public trees. So yes, primarily street trees in our residential areas, but some of the inventories collected by the private tree companies did also include some on private lands. And unfortunately, we don't actually have a good way of knowing the percentages there. But you raise a very good point that, the only data that we had with, that was quantifiable was primarily public trees. And we know that those may have somewhat different characteristics than other trees on people's properties that they choose themselves. Yeah, so that's a good point. I think what this points out perhaps primarily is that, municipalities haven't really been prioritizing low water use trees. So that in some ways may actually be easier to address than trees on private property.
Yeah, if I may, one of the issues that we ran into was a reluctance to try new trees because of the potential impact on sidewalks. Yeah, and then also, you know, there does tend to be a tug of war between because street trees are most likely to be planted in front of a home, what the homeowner wants, because they think of the parkway as their, you know, part of their landscape, and then what the municipality wants, because they're thinking in terms of the streetscape. And then they tend to also favor what's already planted on the street. So, you know, that often very much plays into the selection of the tree. But the most sensitive part of it is not wanting the sidewalks to be ripped up in 30 years.
Yeah, that's a really good point. Thank you.
Absolutely.
Okay, we're going to take one more question, then we're going to take our break. Amy Talbot, go ahead and unmute.
Hi, Chris, can you hear me?
We can. Hi, Amy.
Okay, great. All right, this is Amy Talbot from Regional Water Authority. Just wanted to make a couple of comments if I could. It's my recommendation that the Senate Bill 606 and the AB 1668 regulations for outdoor use should really err on the conservative side, because looking through this tree impact analysis, as we know, it's based on imperfect, kind of incomplete and estimated data, and no fault to the research team. It's just kind of what we have and what we're working with now. But we're not really sure what the on-the-ground impacts will be for trees in real life now and over the next couple of decades. I know as a result of this outdoor regulation, and it's because we've never done anything like this before. You know, for example, we're estimating indoor and outdoor water use, and outdoor water use right now is estimated by first backing out indoor water use, which is also estimated because of there's only one water meter serving the majority of water customers. So what we have is kind of assumptions on assumptions on assumptions, estimates of what the impacts may be. And in those cases, I think it's best to lean towards, you know, more conservative actions until more or better information is available to justify increased actions. You know, something we do know is that in the last drought, you know, in 2015, the state achieved a 20 to 25% reduction in use compared to 2013 use. And the majority of these savings are thought to come from reducing outdoor water use. And if you looked around, especially in the Sacramento region, we saw severe impacts on lawn health, which often include trees built into them. And we know that some of these trees died as a result of the drought and the reduced outdoor watering. And that the Senate Bill 606 and AB 1668, the conservation regulation for outdoor use, will require the same level of savings, presumably for some outdoor water use for some suppliers. And that could produce similar tree impacts that we saw during the drought, because you're simulating essentially that same reduction in use. We also know from RWA's focus groups that we had a couple of months ago, we asked customers specifically what they do to take care of their trees. And the majority of people said that they don't do anything special to take care of their trees, that they assume trees are getting all the water they need from general lawn watering. So if we reduce general lawn watering, there will, you know, presumably be some impacts on those trees. And there seems to be some sort of disconnect between, you know, reducing landscape watering and the need to take that special care of trees at the same time. And even though lawn watering might not be the most ideal tree watering situation, it is how they're being watered now for the general residential population from what we can tell. And for better or worse, those trees are used to that watering schedule and that sort of watering. So that's what they're accommodated for.
Hi, Amy. I think we're going to have to, I'm so sorry. I think we're going to ask you to pause and sort of bring that some of those comments, all very good points that you're making, but we wanted to try to stick to the schedule as close as we could here. So please pose whatever question you might have in the chat. are in the question and answer. And then Chris was also bringing up our website earlier, which shows where you can provide sort of comments. This makes it really easy for folks to click that button. It automatically populates an email for you. So we're about 3 minutes over, and again, we're trying to be very respectful of people's times. So why don't we take our 10-minute break now, which would have us coming back here not at 2:40, but at 2:43. And Amy, if you want to sort of pick your thought back up in the Q&A, that would be much appreciated. And apologies again for cutting you off mid-sentence, but thanks for your understanding. And yeah, we'll see folks back here at 2:43.
Welcome back, everybody. We're going to continue our discussion. I want to remind everybody that there will be additional time at the end of our webinar to ask additional questions. Next presenting will be Melania Fior, who is an executive director of Rescape California. Rescape has qualified over 3,000 landscape professionals employed by over 98 governments and public agencies and hundreds of private businesses throughout California and beyond. Their whole system qualifications educate about 8 principles that assure design, firescaping, and maintenance goes beyond sustainable to establish regenerative landscapes. Rescape practices focus on topsoil regeneration, conserving water, increasing biodiversity, supporting biosequestration, protection of valuable resources while reducing waste and preventing pollution.
Thanks, Chris. Good afternoon, everyone. Thank you for joining. We have a great group of presenters today. The goal of this workshop is to talk about some of the potential impacts of the California 1668-606 proposed standards on developed and natural parklands and urban tree health. We'll be talking on adaptation measures. The panelists are boots on the ground individuals and organizations who will be sharing about their urban greening efforts and water efficiency and the impacts, including cost and challenges in the face of current and future drought, which we all are experiencing. As Chris said, you can type your questions into the Q&A and we will address them following the presentation. First up is Tora Rocha of the Pollinator Posse. Tora was a park supervisor for the City of Oakland Park District for 35 years. Towards the end of her tenure there, she co-founded the Pollinator Posse, which is an all-volunteer nonprofit working to create pollinator awareness and habitat throughout the urban jungle. The Pollinator Posse creates pollinator-friendly landscaping and educates about the need for local ecosystems. Tora works throughout California and the US, and she is also a Rescape instructor. Welcome,
Thank you, Melina. Thank you. And thank you, the California Water Boards, for inviting us. This beginning part was really exciting and interesting, and I learned a lot, so thank you. Next slide. I want to talk about the fact that we all know that planting native plants are going to help in this water conservation efforts to reduce water throughout California. But I want to talk about how important the way we look at landscapes as humans are. And I wanted to use this signage as an example of, I worked at the City of Oakland and I was in charge of Lake Merritt. And I worked there for 37 years, saw the decline in the trees and the parklands
from the existing droughts that I've been through those whole times. And that's when I woke up and said, I need to do something about this. And that's when I started the posse. But it was really my fear of losing our landscapes due to lack of education, not just to us, but to the public. I started letting areas go to be weedy kind of plots so that we can attract pollinators. And I get 50 emails saying, why aren't you weeding this area? Why aren't you taking care of this? Why aren't you maintaining? And I realized I went out there and the weeds were actually really important plants to the universe and to the planets and especially to pollinators. And so I put these signs out all around Lake Merritt that said, pardon our weeds, we're preserving pollinator habitat. The same 50 people emailed me and said, thank you for what you're doing. So I saw a bunch of comments earlier about educating the public. It's so important, and we can use our public spaces to do that, to educate people. The plants that were in that particular area that they were complaining about was plantain, which is a host plant for the buck-eyed butterfly. It's also a medicinal herb that you can use on a poultice for a bee sting, or you can make tea to treat asthma. So why is that a weed? Why is the plantain a weed? And people are weeding plantain out of lawns. I want you guys to all go home and weed out the lawn out of your plantain. Plantain's drought tolerant. It's a great plant for all of us, pollinators and humans. So that's the way, like, I just wanted to point out how signage and professionals in the landscape has the power to change the perception of how people look at landscapes, because that's really the problem. And I realized as a volunteer, as a park supervisor, as a gardener, that everything we do, every single thing we do, whether we rake our leaves, whether we don't, whether we water, whether we don't, whether we compost or not, every single thing you do affects the local ecosystem. So I try to get people not to call themselves just landscapers or gardeners, that we need to train, especially municipal staff at the government levels. We need to train the staff that they're not just landscapers. They're not Colombo guys. They are stewards of our local ecosystems. And we need to start training like that. We need to teach the public that every time they touch the ground, they're a steward of the local ecosystem. And we just really change the way we look at how we maintain landscapes and how we plant them. Next slide, please. Next slide. Oh. So I want to point out, like, this is a native landscape in a yard out north of Sacramento. And she's converted most of them to native plants. I say, actually, because climate is changing, that it doesn't have to be 100% native to your region. It should be at least 70% of native to your region for you to be able to attract pollinators. And then we stick on pollinators because pollinators are the bottom of the food chain. 75% of songbirds feed their fledglings caterpillars. So 75% of the food that songbirds get in the spring are caterpillars. I just want to resonate that. That's a lot. So it's a lot of caterpillars. So we need to plant native plants that attract the native Lepidoptera so that they can have caterpillars to feed their youth in the spring, sorry. Anyway, this is a perfect habitat right here. This is what I consider a perfect habitat. You have to have large trees for the raptors. Plants are able to reach mature height. That is such an important point to make when we're talking about native plants. It's not just that they're native to your region, that they're going to be drought tolerant, but if you have to prune it, overly prune it and keep pruning it, it's going to need more water. So you can't plant plants so close that you're going to have to keep them pruned. That's going to add the need to water it more, because otherwise it's going to get stressed. So make sure when you're designing it and that you give the proper spacing between the plants. I think that's one of the hardest things and the most untalked about things that we're doing in our native landscapes. Anyway, you have lots of nectar to attract the pollinators. You have host plants, which are the plants specific to butterflies that where they can lay their eggs on. You can go to Pollinator Posse. We have a list of what those plants are. Nesting boxes for birds, a small water source that where your sprinklers can hit for the bees. They need water, so we use, you can see where it says water source right above it is just a plant, a pot tray, and we just keep that with pebbles in it, and the bees can land on the pebbles and drink the water. And wood snags for the native bees. People don't realize that it's not honeybees that we're losing as much as we are losing native bees, and we have 1,600 native bees in California, and that's really what the posse does, is we focus on native bees. Next slide.
And if you could just wrap up as soon as you can, Tora. Thanks.
Yeah, okay, sorry. And then here's another beautiful California native garden here, up here in the foothills. And so they can be beautiful, just it doesn't have to be an ugly setting. I mean, that's part of the perception that people think that California native plants are ugly. So this is, I just wanted to show you, nope, they're beautiful. So if you have any questions, you can go to pollinatorposse.org or Rescape, and we can help you design your landscapes to fit your region and save you water. Thank you.
Thank you, Tora. That's great. Lots of really important information, including on your website. Next, we have Mona Nyandaro Cummings, who is the CEO of Tree Fresno, which is a 40-year-old nonprofit devoted to transforming the central San Joaquin Valley with water-wise, large canopy urban trees. Over the years, Mona has worked in tropical forestry in Lusophone, Africa, where she learned the importance of maintaining awareness of people's resilience on natural resources. Mona holds a BS in biology from Missouri State University and an MPA from Fresno State. Welcome, Mona.
Thank you. Can you hear me?
Yes, we
Great.
can.
Okay. Well, thanks for the introduction. I'm presenting from the perspective of a small nonprofit focused on the expansion of the urban tree canopy. So again, I'm Mona, and I'm CEO of a nearly 40-year-old nonprofit devoted to the planting of urban trees. Since 1985, Tree Fresno has planted more than 51,000 urban trees throughout the central San Joaquin Valley. We specialize in providing trees to schools, churches, parks, and along streets and busy roadways. We also steward a variety of community partnerships, offering the planting and establishment care for more trees than we could possibly do alone. Between October and May each year, volunteers come out by the hundreds, each one inspired to plant trees and make the world a better place. So why trees? As one of the founders, John Valentino, told me soon after I joined Tree Fresno, in our minds back in 1985, and frankly, that still hasn't changed much, the tree was identified as an ideal solution, at least part of the solution, an ideal technology for addressing many of society's most pressing issues. Indeed, in the valley, native trees were limited to riparian areas. Frankly, there just weren't a lot of trees here 100 years ago, but after moving 1 to 2 million people into the region, in over 100 years, planting trees seems like a prudent thing to do. So it's true that trees clean the air, the water, prevent soil erosion, provide shade, especially in these hot areas of California. They help people save on utility bills, reduce stress and violence, increase property values, provide homes for animals, serve as windbreaks, and capture dust and pollutants. So this is why we plant trees here. Every tree works to sequester greenhouse gases, but some do more work than others. In our opinion, bigger is better. So if trees reduce atmospheric levels of greenhouse gases by transforming the gases into living matter, it stands to reason that the bigger the tree is, the more carbon it's storing. In Central California, a large evergreen oak will have sequestered nearly 9 tons of carbon dioxide after 50 years. We exclusively at Tree Fresno plant water-wise large canopy trees, which require as little irrigation and water as necessary to produce a vibrant urban tree canopy. Longevity is important. The carbon dioxide that's stored in a tree only remains trapped as long as the tree is alive. And once the tree dies, begins to decompose, the greenhouse gases it sequestered will return to the atmospheres. So the longer they live, the longer they are able to combat climate change than the shorter lived trees. Though we receive individual donor contributions and support from local businesses, the bulk of our funding to support tree planting is currently derived from state grants, which are specifically designed to increase green space in disadvantaged areas, according to EnviroScreen 3.0. Tree Fresno works with cities, educational institutions, public agencies, and others to encourage the planting of water-wise large canopy trees. Over the years, we've consistently received funding through CAL FIRE Urban and Community Forestry Program, which requires designated irrigation and long-term maintenance and care for every 15-gallon drought-tolerant tree planted. So far, we've planted about 7,500 trees through recent grants managed by CAL FIRE since about 2016. Tree Fresno currently has a staff of 3. We're a very lean operation, but that's because we're able to do a lot here. Aside from a modest injection of local philanthropy in our state grants, we have a California Air Resources Board Special Environmental Project we refer to as a SEP, which features a partnership with Sonoma Technology to construct research-supported vegetative barriers to protect nearby communities from road pollution. They measure the air quality and we plant vegetative barriers. The majority of our planting is targeted towards disadvantaged communities per Cal EnviroScreen, and they're specifically targeted for investments of the proceeds from the state's cap and trade program. My role here is to spearhead the planning processes that result in more trees being planted and cared for on the grounds of schools, parks, and public spaces. We have a lot of partners, including cities, counties, public agencies, nonprofits, CBOs, private industry. We partner, and we encourage water-wise landscapes, including the elimination of lawns, and discuss the trade-offs of how to spend water. We encourage the keeping up of irrigation, repairing it, adjusting timers, and not letting water wastefully pool or run down the street. In short, Tree Fresno advocates irrigate trees, forget the grass, and give up on other wasteful water wasting activities. So finally, bottom line for this session today, Tree Fresno specializes in the planting of large canopy drought tolerant trees throughout urban areas in the valley. We encourage our partners to keep watering the trees, to give up on the grassy turf, and to understand that it's going to be more expensive in the long run regarding to the benefits that are diminished because of the death of trees. It can be very expensive to cities to take out trees in the future. So that long-term value of a healthy, vibrant urban tree canopy cannot be emphasized more during these times, and we are advocates for keeping trees alive. So thank you.
Thank you, Mona. Really grateful for your work. Thank you. That's really wonderful.
Thank you.
Next up, we have Lindsey Stuvek, who manages the Water Efficiency Department at Malton-Nagel Water District. Her career has been dedicated to developing sustainable, data-driven water efficiency solutions and customer engagement strategies that can be replicated and adapted across the industry. Lindsey has a master's degree in urban and regional planning from the University of California, Irvine, and a bachelor's degree in political science from California State University, Fullerton. She is also the recipient of the Switzer Fellowship from the Robert and Patricia Switzer Foundation. Welcome.
Thank you, Melina, and thank you to the state board staff for having me. I'm excited to speak today. I guess I am the representative of the water utility sector. So Malton-Nagel is located in South Orange County. We serve water, recycled water, and wastewater to about 6 different cities, about 170,000 residents. Another interesting stat is about 75% of our customers live in an HOA, and we have over 400 HOAs just in our service area. So in addition to discussing cities and municipal greening, we're also talking about kind of this other level of management of landscapes. And so that's something that Moulton has been very proactive with. And I'll talk a little bit about that. So the district has had a water budget-based rate structure since 2011. That water efficiency fund, or essentially that any type of over allocation or over budget revenue that we receive accumulates in a water efficiency fund that we reinvest back into the community and into efficiency efforts for all different segments of our population, residential, CII, public agency. All of our, not even just our potable customers, but our recycled water customers have a water budget. So our ET adjusted factor for recycled water is 0.8. And our ET adjusted factor for potable water is 0.7. It didn't start out that way 10 years ago, but it has eventually settled there. And we look at that 0.7 for potable water as kind of a mix of warm weather turf and California native plants. And the district has been very proactive about promoting California native plants and their benefits, not just the overall reduction in water demand that you can realize by planting them, but there's benefits to peak shaving, as you'll see if you can go to the next slide. Developing habitat connectivity, and resources for pollinators and local bird populations. So we provide a landscape workshop to our residents, as well as a H2O for HOA workshops for our local HOAs and professional landscapers and property managers. And some of the things that we try to do is educate them on the seasonal water requirements of different types of plants. And so we've put together the next 3 series of slides that I'd be happy to share with anybody on this call. But as you can see, that green line there is representative of the plant water requirements for warm season grass. The purple line is drought tolerant plants that are non-Mediterranean. And that yellow line down there at the bottom, that is the plant or the monthly plant water requirements for our summer dry California native plants. And next slide, please. And I feel like whenever we present these slides, this is really the slide that hits home, this combination of the first slide and the second one, where we show them a 5-year average of precipitation during the previous drought. When we talk about drought resilience and trying to implement adaptive changes to our landscapes to really make us more resilient in the future, I feel like this really hits home because it shows them that these California native plants, these summer dry in particular, have really adapted to our precipitation schedule. And even like during years of drought, there's very little supplemental water that's needed to keep them alive. Next slide, please. And so we took these different lines and we basically created a comparison of supplemental water needs. And so if you're looking at like our warm season turf compared to our natural rain cycle, or at least our 5-year rain cycle during the previous drought, there's quite a bit of water that's needed, and the peak amount is needed in the summer. Even for those drought tolerant plants like your cosmos, your hibiscus, that they may need additional amounts of supplemental water even in the summer. But if you can see, you really minimize the amount of supplemental water that's required just by installing those summer dry California native plants. And so because of those benefits, we really advocate for not just our residential customers, but our commercial customers to install California natives, everything from ground covers to trees to different types of shrubs. We have a landscape workshop that is specifically focused on watershed friendly landscaping. We've had about 3,000 customers attend that workshop, and we provide them with information on natives. And I feel like it goes back to education. A lot of folks still just aren't aware of the benefits. And I think the even greater challenge is that now that they're aware of these benefits, how do they get access to these plants? And that was something that we've run into over the last 7 years of hosting these workshops. We'd talk all about the benefits, and then people would ask where to find them. We're like, well, you have to go to this boutique nursery that's down this street, and you have to turn left, and you blink and you'll miss it. And so we partnered with Metropolitan and the California Native Plant Society and 15 other water agencies in Orange County and Long Beach to put together a CalScape nursery training. Part of what we did is we surveyed nurseries across the state to see why they don't carry California natives, and what do they think that they need in order to be successful in selling natives. And the 2 greatest responses that we got were, we need education for our staff, and we need marketing materials. And so through this pilot and collaboration, we developed a CalScape nursery training. It's a 8-part training that teaches essentially nursery staff how to maintain California natives in the nursery environment, as well as how to explain their benefits and management to people that are trying to purchase them. We've also developed a direct installation program for our residential customers. We call it our Naturescape Turf to Native Garden program, where we provide customers with an educational seminar. We do a free landscape assessment. We provide them with an all native design that's watershed friendly. So it'll include a swale or some type of rainwater capture device and discounted installation. And we've had about 120 folks participate in that. And we've also got a ton of different opportunities that we've provided for HOAs. And I know I'm running short on time, but I did want to mention the previous panelist mentioned that bigger is better and that biomass of trees is really important. You know, with HOAs, we've realized that there's a lot of misconceptions, and a lot of the folks that sit on these boards are volunteers. And so one of the things that we've noticed in our service area is that a lot of HOAs have CC&Rs that limit their trees to 30 feet in height. And so you immediately cut down on your tree palette and what's available. And so I think that in looking at educational opportunities, it's not just about educating our municipal governments, but also looking at HOAs, which you'll find are pretty common in the Southland. And so I have a lot more resources to share, but I'd be happy to discuss them further. Or if you want to email me, I'll put my email in the chat. Thank you.
Thank you, Lindsay. Your water district is known as a model district for education. So thank you, it's great. Those are some really impressive data slides. Next we have Brooke Sarson, who is the CEO of Catching H2O and has 13 years of expertise in landscape retrofits for water harvesting and conservation. Catching H2O provides solutions in water supply, stormwater pollution, and wastewater management issues. Brooke is speaking today as a technical advisor to Accelerate Resilience LA, or ARLA, which works with communities, organizations, and governments to expedite climate resilience. ARLA is an organization started over 40 years ago in Southern California by Andy Lipkiss of Tree People, an organization uniting communities to plant and care for trees, harvest the rain, and renew depleted landscapes using their unique citizen forester model. Welcome, Brooke.
Thanks, Melena. Over the years, I've installed hundreds of gray water systems, and by far the best or most common feedback that we get is my tree has never been this productive. And I think what this indicates is that, you know, a lot of us in Southern California have a drought mindset. So we're watering our plants so that they can survive, but not that so that they can thrive. And when we start to realize that we have a lot more water resources than just municipal resources, we realize that we can actually enhance our plant palette and enhance the ability for our plants to thrive. So what we focus on is using on-site water resource, non-potable resources like rainwater harvesting in cisterns and passively in rain gardens, using gray water, which is water from showers and sinks and washing machines, and even things like AC condensate or whole house filter flushes. And using these not only at residential scale, but even commercial scale, you know, for example, AC condensate that's generated from commercial buildings can keep a very viable landscape going. So these are just some tools in the tool belt of having a healthy and biodiverse urban forest. What we like to also focus on is keeping our soils healthy, which I know people have talked about in the presentations so far, using mulch and compost. But by being able to consistently apply water and having maintaining healthy soils and biodiverse plant life, we're actually, next slide, please, nurturing an underground mycelial network that is actually passing nutrients and resources around so that plants and trees in some areas that are not able to have their own water resources or nutrients can get those from other nearby plants and trees. And so what we're seeing from this is that we can actually have more abundant landscapes with less water if we are harnessing all of our available resources and keeping our soils healthy. Now, the costs associated with these kinds of things can range widely, and anywhere from like simple do-it-yourself options to like creating rain gardens and planting appropriate plants, to a simple laundry to landscape gray water system, for example, as seen here, where we can teach people how to install their own system in about 4 hours on a Saturday, and they can go get the materials from Home Depot for about $200 to $400 and put these systems in and be watering several trees in their yard and cutting out the municipal needs for those trees. But it ranges, so you can have more expensive installations that require pumps and filters, or buying cisterns. And the key here is that there are residents all over California right now implementing these water conservation strategies at their own cost. And while much more expensive solutions are being focused on at the municipal level. So we suggest and recommend that we focus more education and more rebate potential to these kinds of options. They're decentralized, they're location specific, and they can be widely used to cut back on our municipal supplies while creating more diversity and more abundance in our communities. Some opportunities, which I loved what Mona was saying about Tree Fresno and all of their partnerships. There's so many opportunities to pool funding and leverage other funding sources because of the myriad of benefits from these kinds of strategies. For example, the City of San Diego's Stormwater Department was the one that instigated and funded rain barrel rebates as a way to mitigate stormwater issues, but they didn't necessarily maximize the opportunities for water conservation. So there's room for collaboration there. Climate action plans are another great way to find funding resources, because as many people have said in this presentation, growing trees and having diverse landscapes is really benefiting our communities in so many ways, from public health benefits to carbon sequestration, recreational benefits. And not only all of this, but we can reduce the need to keep expanding our expensive wastewater treatment infrastructure, for example, if we're rerouting our gray water into our landscapes and keeping the nutrients in that water in our landscapes. We don't need to strip out all of those nutrients and water our plants with potable water to create benefits. In addition to all of this, these kinds of solutions can generate local quality green jobs like plumbers and landscapers and contractors and business owners, while improving water supply and water quantity. And as Mona was talking about, she partners with the fire protection, and there's also flood protection benefits with all of these kinds of strategies. We know that incentive programs and rebates need to be prioritized for disadvantaged communities. For example, Tucson includes a small fee in the base rate for all customers for low-income assistance. This goes to providing enhanced rebates for qualifying customers for rainwater and gray water systems. Direct install programs are helpful, which Lindsey mentioned before, and our recommendation is to plan and implement distributed green infrastructure at scale. To transform at scale, we need to transform all types of parcels: homes, streets, parking lots, ball fields, schools, parks, commercial, industrial spaces. We can use AC condensate. We can use water from water fountains and hand washing stations to develop healthy urban and semi-urban forest watershed. One of my mentors says the cheapest options, the most ecological solutions are usually the most economical solutions. And so, we can see that here, where we're embedding a lot of opportunity into creating these ecological solutions, but they're low-hanging fruits, and we really need to educate people about them and create incentives, and we'll be investing less money overall in more benefit. Thank you.
Thank you, Brooke. That was really great. I don't see any questions in the Q&A. Am I seeing this correctly? So no one has entered it into the Q&A. Anyone raising their hand for questions to the panelists?
So I just reset the hand raises that were left up from the previous comment section. So if you have a question, you can either raise your hand, we can answer it live, or you can place it in the comment box.
Okay, well, while people are thinking, I would, were you going to say something, Chris? Sorry to interrupt.
No, go ahead.
So I was going to just start to ask some of questions that came up for me as the presenters were speaking. So Mona, what are some of the kind of issues that arose, you know, in your work planting trees that you kind of resolved and that you would suggest for participants in the future to kind of build a robust tree planting program, you know, in a city or region, based on, you know, this is the third year of the severe drought, as we know, and we're going to have more. So what would you suggest?
Thanks for the question. And I would say that I emphasize with partners and potential partners that we think of long-term. So establishment care is critical and usually provided through the grants that we receive through CAL FIRE and also the finding program through CARB. We actually prioritize it, and we do quarterly checks on the trees that we've planted, and we follow up with our partners. So from the get-go, whether we're working with the city of Fresno or we're working with a school district, we make sure, and they're very accustomed and understand the responsibility that when they plant trees with a professional planting organization like us, that they are absolutely responsible for caring for the tree enough to where it will survive into the future. So I think it's very important to actually explain to all those involved, including potential partners who sometimes contact us and want to give us money to plant trees, that we actually don't need money to plant trees. We need the concentration of efforts to be on long-term maintenance and care of trees. So it's not just about going out there and planting 700 trees. It's actually what's going to happen after those trees are planted in the ground. It's a wonderful day when those trees are planted, but we look at it as, okay, how do we strategically attend to those trees so that we can be sure that at least at the 3-year point that they're still alive and that our partners know what it takes to keep them alive. So I would say that it's quite important to be or to have a presence as an organization like ours that keeps our partners accountable, keeps the cities accountable, and shows up and makes comments and advocates for investment in tree preservation.
Thank you, Mona. Yeah, you've brought up a point that I think is an issue across all industries in the world, which is maintenance. What happens after the design, or what happens after the construction, or what happens after the install? 6 months, a year, are those plants pulled up, or is there enough mulch, et cetera, et cetera. So that's a really important point in terms of maintenance, including the shifting best management practices on care, based on drought and, decrease in rain, et cetera.
I'd like to add to that because there is an excuse that comes up sometimes when we visit a park and all the irrigation is off, or a school and all the irrigation is off, is that we will follow up and put pressure on those, those hosts to those trees, that the trees need to be watered. We understand that the grass can die, but the trees need to be watered. And I think that it's actually the place of an organization like ours to be that advocate for trees. And again, informing them that actually the death of the trees on your campuses or on your facilities is actually going to, in the long run, be more expensive. You're not going to have those benefits from the trees that we, the short-term gains are not worth it.
Mm-hmm.
We need to make an extra effort.
Yeah, thank you. We have a question from Cody Harrison. Why isn't more emphasis placed on caring for large mature trees and the soil they grow in, given that they provide the vast majority of environmental social benefits? I think probably all of you could answer that, but who wants to take that answer first? More emphasis.
I can take it.
Okay. Tora, Mona, Tora first.
Cody, I just want to thank Cody for asking that question, because it's really valuable. And as a park supervisor for many years and working in municipal settings, we had all this push to plant new trees all the time, and nobody really, talking about the existing trees, but there is definitely a conscious shift right now about that. It's in its infant state, this paradigm shift. So I do believe, Cody, that you will be seeing more of that. But there is, we have another thing that no one's really talking about. I have witnessed a clash between CAL FIRE and their grants planting things, and then individual fire districts saying that you have to remove these trees because of fire. And so that's where we need to push this emphasis on those, existing trees, mature trees need to be saved. There is definitely a clash happening, but I do see this shift in the paradigm. So I bet Mona can piggyback on that one, but thank you for asking that question.
Thanks, Tora. Mona?
Well, and Tora was talking about parks. In our community, sometimes we get phone calls from individuals in neighborhoods, residents who are concerned about trees being taken out in other people's yards and properties. There really isn't, from my point of view, enough protection for preventing that or making it more difficult, because those are private properties. I think when Tora was mentioning, for fire protection, it's very difficult to argue with that, and vegetation management. So honestly, we do not spend a lot of time arguing that unless it's a specific case where it seems like we would win that argument for a tree on maybe a public property that's historic and that's providing all the benefits. There needs to be policy in place in these cities and these jurisdictions to actually support or to make more complicated the extraction of larger trees and to preserve those trees.
Mm-hmm. Thanks, Mona. Brooke, I wanted to ask you what specific input you have about trees vis-a-vis your company and your work. Do you have any additional services that you provide, or education, etc.?
Well, yeah, we have educational programs about implementing rainwater and gray water systems for sure. One thing that we focus on is, I know that there was a lot of talk about moderate or trees that need a little bit more water than, say, a California native, and that these are pretty common in, maybe the public spaces that are being inventoried. But a lot of our focus is for residential is, being able to grow food in your yard. And so it's fruit trees really. And so, when we're looking at drought restrictions and we're looking at the investment of somebody who has like a 10-year-old or 20-year-old orange tree or something that they're getting food off of, and maybe even too much food that they're donating to the food bank, we don't want to see these trees die either. And we don't also need to necessarily use more municipal water than other landscapes to keep those trees alive and healthy and thriving. Because we have gray water opportunities, hundreds and hundreds and hundreds of gallons a week of gray water to be able to grow food in our backyards. And the reality is we have this invisible water footprint attached to the food that we go to the store and buy, so every element of food that we can grow in our yards and maximize our water resources to do that is also reducing our overall footprint for the whole state and for the whole West. So a lot, and the great thing is that gray water has a lot of added nutrients in it. The soaps are not bad. They actually have nutrients in them, but we also have, dead skin cells coming off of our bodies or whatever. And all of that goes into feeding the microbes in the soil and creating more nutrients for trees to grow healthier. And so that's kind of a focus element for us.
Thank you. Lindsey, do you have something you would add?
Yeah, I was going to add to that too. I think, there is a focus. I know that a lot of the utilities will offer like a turf replacement incentive. And we've also been recently really promoting a spray to drip incentive. And so as part of those turf removal projects, there really is an emphasis on trying to keep trees in place, but just replacing the turf. And with the current projects that are being operated in Southern California, the materials that are used to actually upgrade irrigation systems, so replacing your spray and going to drip, are reimbursable through those programs. And so that's one way that you can maintain some of those trees in the landscape, even by switching out the other type of landscape materials that are on the ground, particularly turf. And again, one of the things that we found that's very successful is our commercial spray to drip program. And so even if you did want to let the grass brown out, you could convert some of those spray heads to drip and still be able to target water those trees.
Great, thank you. I think we're probably at time now, is that right? Yeah, looks like it.
Yeah.
So thank you all, and thank everybody for your attending. We really appreciate you, Tora, Mona, Lindsey, and Brooke.
Thank you. Thank you for having us.
Thank you.
Thank you, everyone.
Thanks all.
So next we have Walter Passmore, a state urban forester with CAL FIRE, with CAL FIRE's Urban and Community Forestry Program, who will speak about CAL FIRE's funding opportunities.
I think, Chris, that I was actually going to give a sort of quick overview of some of the, of the announcement that came out yesterday. If you could advance to the next slide.
I am terribly sorry.
And then to Walter, yes. So hi again, all. I'm Charlotte Ely, supervise the conservation program at the State Water Board. Many of you may have seen yesterday that Governor Newsom announced the latest actions that we're taking to increase water supply and adapt to more extreme weather patterns caused by climate change. One of the stats that really has, I think, stuck with me and a lot of people is the idea and the projection that hotter and drier weather conditions spurred by climate change are going to reduce California's water supply by up to 10% by the year 2040. So to help replace and replenish what we're going to lose to thirstier soils, vegetation, and the atmosphere, Governor Newsom and leaders at from the State Water Board and DWR announced actions that we'll be taking through this strategy document, adapting to a hotter and drier future, which is linked to in this presentation and also can be found really easily online right now. So to build on the actions of the last 2 decades, the strategy outlines, what we're going to be doing to both expand supply, but also to reduce water demand. It calls for, Californians reducing our annual demand by at least 500,000 acre feet by 2030. And to do this, it highlights some funding. So for one, the strategy directs the department and the State Water Board to help local water districts achieve these objectives that are called for through the Making Conservation a California Way of Life regulation. And this will in part be funded with funding that was recently approved by the legislature. The 2022-2023 budget includes an additional $2.8 billion for drought relief for hard-hit communities, and that includes water conservation, environmental protection for fish and wildlife, and long-term drought resilience projects. It also directed the department to establish a new grant program to support local efforts to replace ornamental turf with drought-tolerant landscaping. And where, schools and parks require turf, to make sure that turf is irrigated efficiently and those irrigation systems are maintained, and to really emphasize getting these resources out to disadvantaged communities. So just wanted to encourage people to scope out that document. If you have not yet, there's information about this funding and actions that we'll be taking here in the state of California. Additionally, many folks may have seen that the Senate and the House nationally have passed climate change legislation, and in that there will be funding for drought relief in the West. I think I saw something, it was $4 billion for drought relief for Western states. So this is a good time, and that there are resources to help us with this great transition that we need to make as a state and within our communities. So just wanted to highlight some of those resources, and with that, pass it to Walter. Thank you so much for joining us today, Walter.
Thank you, Charlotte. You can go to the next slide. This is just the title. So, Urban Community Forestry Program, in relation to the huge amount of funding Charlotte just told us about, is a relatively meager program, but I think very important. You heard from Mona with Trees Fresno, which is one of the many recipients of CAL FIRE grants. We also provide technical assistance and advice, public and professional education. We attend events, we do advocacy, create partnerships, facilitate technology transfer. So, getting the research into the hands of the people that need it, and we're a conduit to national programs. So, all of these influences combine to help us grow healthy trees with the smallest investments, the least amount of risk, and optimizing the benefits. Next slide. So here's a little bit about our program. We have a relatively small staff of 10, where we currently have 3 vacancies. So we're actually a staff of 7 right now. I am the state urban forester. I serve as the program manager. Couple of websites of useful information, but we have many more available through our networks and our newsletter, etc. We do provide some funding to networks like California Relief, which encompasses 80 plus nonprofit groups throughout the state that are all focused on urban forestry. We have grants, which is the subject of today's conversation. Last year, we gave out $30 million to 40 grant awards. Put a link to where those awards are located. This is a historic high for us. Previously, the most we had given out was $20 million. And over the last 6 years prior, we had given out on average about $12.5 million. Next year, for 22-23, the legislature and the governor have really been attentive to urban forestry issues, and the proposal is to deliver $85 million in grants. There is increasing recognition of the value of urban forests to public health, to addressing the issues of climate change, to addressing local pollution, air quality, outdoor recreation opportunities. a laundry list of benefits. So we do award grants in different categories. These are the ones that we awarded last year. Urban forest expansion and improvement is essentially tree planting and surrounding activities. So we do fund things like improved irrigation systems, improvements to soil volume and quality, as some of the previous speakers had mentioned as being important attributes of growing healthy, thriving trees. We fund management activities because we recognize that the tree planting is just the first step. It's also important to have policies, budgets, partnerships that support those long-term investments, that support the maintenance that needs to happen, and that we have funding mechanisms that come alongside limited budgets to support these activities, especially in disadvantaged communities where those activities are needed most, but they're also least capable of affording to make those significant improvements. This past year, we added workforce development. So training people at a local level to give back in their own region, train the next group of professionals to contribute to solving problems where they are. And this coming year, we're going to be adding a couple of more grant type categories. One is green schoolyards. Despite the lack of canopy in some areas, schoolyards are historically even worse than our worst communities. Schoolyards have traditionally focused on building out asphalt and facilities, and with changing climate, some of those spaces covered in asphalt are becoming intolerable for students to even utilize during the day. So definitely more focus is going to be on green schoolyards. I am going to skip over these next couple, so let's go to the next slide. Just in the interest of time, this is the 5 minutes of everything you wanted to know about urban forestry. There's a lot of benefits. I am not going to go over all of these, but probably pertinent to today's conversation is urban forests are an opportunity for us to improve water quality, do on-site treatment, improve water availability for plants, because as we improve soil and we have trees growing in that soil, then we create a healthy ecosystem that can be largely self-sustaining. So, we're trying to change the mentality from the historic where we, have to have a fully developed property lot line to lot line to something that embraces ecosystem services to the extent possible. Next slide. These are our grant types that I mentioned. I am not going to go over those in excruciating detail. So let's go to the next slide. So program history and forecast. I think this is probably relevant to today's conversation. We do have some foundational services. Grants are one of those, but we recognize that money doesn't solve all the problems. Folks also need technical assistance. They need to know the advice of experts on how they build programs, and each area is unique. Each area has its own unique problems, and the groups that can contribute to the solutions have unique needs and culture and so forth. But we recognize that when people come together to solve a problem like the lack of tree canopy in their community, that we create a new culture, and that brings people together in a common mission. So that is part of our approach to improving urban forestry programs, is to create strong partnerships and to forge relationships of trust. So we don't want to show up as the government, we're here to help you. throw some money at a one-time solution and then leave. We want to invest in communities over the long term. That's why we have regional experts strategically positioned throughout the state to interact with communities, whether or not we're giving them a grant. We also have a lot of education and outreach services. So hopefully the message of the benefits of urban forestry gets out to people, and people choose to do the right thing because they want to do their part to address things like climate change, and doing that one action at a time, one tree at a time. Forecast, we are going to be much more focused on big picture, canopy cover distribution and density as opposed to single tree plantings. So we want to recognize meeting the goals of communities and of groups. We want to focus on equity. Disadvantaged communities were mentioned by several of the previous presenters. They are equally as important to CAL FIRE. In fact, historically, we have dedicated over 75% of our grant funding to disadvantaged communities. We are committed to continuing to do that or even increasing that number. We also want to address the problems of extreme heat, climate change, air quality, health impacts, and a multitude of other problems. Next slide. Okay, and there's just some pictures of happy participants. So, hopefully at the end of this brief presentation, everyone is going to be chanting urban forestry, and everyone's going to want to participate. Next slide. So, more pictures of solving some of the problems that we see every day. Bottom right is a schoolyard that we facilitated planting some trees, and that's one of our big challenges for the future. We have 10,000 K through 12 campuses in the state of California with millions of students, and way over half of those campuses have less than a 5% tree canopy cover, where the average for the state is 15%. Our schools are very, hot, dry, barren places covered with asphalt in most communities. Next slide. And this is some of the technical information that we have on canopy cover assessment. We are in the process of updating that this year, so we'll be able to inform decision makers where to focus efforts. Next slide. And that's it. I know I went through that as a whirlwind presentation. Typically I take a little bit more time, but out of respect for all the other speakers, I will quit there. Willing to answer some questions whenever the time is appropriate.
Thank you, Walter. Okay, so now we reached our final Q&A section, and we have Elizabeth with her hand up. I'm going to ask you to unmute.
Hello. Sorry, my question was actually for the previous one, so I'll let people with questions for this round go first.
Okay, so just to clarify, this Q&A section covers the entire presentation for today. So,
okay.
Go ahead.
Okay, thank you. All right. Well, one of the things that I've heard over the thrust of the conversation is that the desire is to, sort of collectively by everyone speaking, to get people to prioritize watering trees over watering lawns, which is something that we absolutely agree with. Although I think that it's worth noting that it's something that we shouldn't take for granted is on everybody's priority. However, it's important to make sure that people know how to do it, because trees and grass have different watering needs, and trees do need that deep soak of watering. So as the state board looks into rebates and equipment, one of the things that would really help was mentioned earlier was soaker hoses. And in fact, soaker hoses could be bundled with stakes that, stake them out in the right way, and timers that adjust to the spigot to be tree watering kits, which could be given away rather than offered as rebates, which would be much more sensitive to lower income households. And because a lot of people, as much as they might want to replace their lawn with something beautiful, they may not be able to afford to do that. And a lot of people simply just turn the sprinklers off in a drought. So providing that kind of support is going to be really crucial as we move forward to try to reach these water objectives. So that wasn't so much a question as a comment.
Thank you, Elizabeth. Charlotte, did you want to respond?
Oh, just to say, and I was actually emailing with Elizabeth earlier that I think the idea of a tree watering kit is fantastic, and I am curious whether any of the municipalities on the line, or if any of the urban retail water suppliers on the line have offered that kind of that resource to customers. Always just add something in the chat if you have. And I did see that there were a number of other questions that were posed in the Q&A, Chris, so perhaps we could.
We have one more hand raise from Tora Rocha.
Oh, sure.
Yeah, I have a question for Walter. So Walter, would CAL FIRE maybe be interested in like the whole tree planting and how you're changing the way you're looking at that now, instead of single tree planting being your focus? What about doing a healthy soils initiative through CAL FIRE instead of just waste management, so that it's taking care of the mature trees? I mean, composting when you do the soaker hose is going to make a huge difference for these mature trees. And I don't really see that emphasis in the CAL FIRE. I know that you talk about technical stuff, but I'm out for like disadvantaged communities to be able to get compost from maybe the local waste managements or something.
So we are pretty flexible with what we are allowed to do. The Urban Forestry Act, the state statute that enables us to act, is very broad, and it does include activities like healthy soils and watering strategies to improve tree health and longevity. So we are certainly receptive to looking at a project like that. And another grant type that we're going to be adding this year is regional or statewide impact projects. We're going to have a lot more funding available in that grant type. So I would love to talk to someone who has a creative idea on how we can improve tree health through a broader initiative like that. My contact info was at the end of my presentation. So reach out to me. Let's have a conversation on that.
Yeah, I have a few people in my toolbox that would love to work with you on that one.
Great. We're all about partnerships and collaboration.
Exactly. Thank you.
Walter, there was another question for you specifically from an anonymous attendee. The person asked, do the CAL FIRE grants only apply to disadvantaged communities?
No, we do have an emphasis on disadvantaged communities, and I mentioned about 75+% of our funding has gone to disadvantaged communities, but that does leave some amount of funding for other communities, especially where they are creating projects that can be modeled or replicated in other places. So, that's important to emphasize. And, just to be frank, we are not looking to help the most affluent communities in the state, because that's not really the role of government, in my opinion.
Good.
Walter, this may also be a question for you, and perhaps Milena, for you as well. An anonymous attendee asked, we'll just point it out that our focus today has been on urban areas. And this person is curious about what sort of initiatives and funding are available to help non-urban areas transform their landscapes.
Yeah, actually, urban forestry is a really tiny component of CAL FIRE. Most of our grant programs are focused on rural areas. So we do have a number of grants listed on our website for rural assistance, whether that's vegetation management or forest health initiatives, technical assistance for rural property owners. I focused on urban because I felt like that was most of what our audience was today.
Charlotte, I can address sort of grants that are available for rural and like ranchers and really rural. There's a lot of grants for native pollinator habitat through Xerxes Society and MJ Monarch Joint Venture. There's so much actually funding going into creating hedgerows and native plants in the rural setting, and it's not about underserved communities. So there are definitely grants and programs to convert your landscape to native for the rural. And maybe I can send those links to you guys and you can put it on your water board. I think I did. It's actually in my slide thing.
All right. I'm not sure if any of the questions that are, or comments that are, questions and comments that are left in the sort of Q&A are things that I could, I'm not sure how exactly to pose them, but we can always look to them later, or you can email us specifically. We use the questions that are posed in these discussions to develop an FAQ document that eventually will be posted on our website. But seeing that there are no more hands up, I propose, Karina and Chris, that we move to the last few slides and close the webinar. Take it away, Karina.
Sure. Yeah, so these are just some links to some of the State Water Board and Department of Water Resources sites around this work, the 2018 water use efficiency legislation. This presentation will be posted online, so you all can check out the links on here, and we've also shared a couple of links on the chat. Next slide. So as we mentioned throughout the presentation, this is one of a couple of presentations we've done around this work. The methods around the work for wastewater, trees, and parklands were presented in early December of last year, and the wastewater results were presented last month? 2 months ago in May. The slides and the recordings of these webinars are on our site. And next slide. Yeah, so thank you so much for all of you attending. We appreciate the comments, and we realize not all of you may have had the opportunity to share your thoughts and comments and questions, so please feel free to email us. Chris screen shared our website. There's also an opportunity to provide comments via the website. And that's it. Thanks.
And thank you too for all of our co-panelists and co-presenters. Really appreciate you setting aside the time to join us on the workshop today. So thank you all very, very much. And happy Friday, everybody.